we have nowadays, that it is possible to fabricate lasers that are not only in the visible regions. You see, visible region is only a small fraction of the whole spectrum of electromagnetic waves. Whereas we have been able to fabricate lasers which range from radio waves, microwaves, infrared waves, visible waves, also ultraviolet to X-rays. And the main given to microwave rays specifically is the lasers, which have been using very extensively in the research purpose of inter-satellite communication and all that. So why this laser is being given so much importance? Because whenever, let me ask you a question, when I ask about wireless communication, what comes into your mind? So सबसे पहले क्या आता है? Waves, radio waves, antenna, and all that. Nobody can think of laser. If someone think, we cannot think of applications of the laser. We are using lasers. But trust me, अपनी lifetime में you all communication is anything that can impart meaningful information. Okay, agree or not? Communication is anything that you can please interrupt me wherever you can. Okay, wherever you seem like that you are not understanding. So you people who are the hosters, also who are residing in the Indrapuram and all that, this region has a very good fiber optic backbone. You understand about fiber optic backbone? Okay, the transmission lines, transmission lines, everybody knows transmission lines. The transmission lines used nowadays is being replaced by optical fibers because of its high speed. I'll give the benefits of the optical communications later on. So you all are contributing to the laser communication using community. Okay. So, but still, this area has been given least importance in field of research, but it has huge potential. So, what is the property of a good communication system?
Less bandwidth.
Less bandwidth or high bandwidth?
Noise control. Less signal to noise. Signal to noise.
Okay. Anyone else? One analysis. Very good. Alan should be high SNR. Those students who do not know SNR, it is a signal to noise ratio. Okay. It should have low BER. BER is the bit error rate. It is the erroneous signals divided by the total amount of signals. It should be power efficient. It depends on the channel. Okay. If we have a limited amount of bandwidth and we have to put these number of channels on it, the bandwidth allocated by each channel. Bandwidth of the total communication system must be high. Okay, the data carrying capability must be high. But if we have divided and we have imparted the channel that this much data you have to carry it in least amount of possible bandwidth. Band is the spectrum of the bits and the signal that can be carried in it. Okay, so bandwidth becomes the in limited part the spectrum in which the bits can be carried. And basically we are using RF terms, radio frequency terms in it. All the mobile technology and all that, RF terms are being used. Okay, so government has allocated a fixed amount of bandwidth to RF technologies, to medical bands, to defense and all that. So RF companies all over Vodafone, Airtel have to put their limited the number of customers, maximum number of customers in their limited bandwidth. Getting it? Everyone got it? Okay. So what are the other properties? It must be power efficient. It could provide data security. Data security is one of the very complex topic nowadays. BR is a bit error rate. Okay. Suppose I have sent 1010101. Okay. But I received 1101001. Okay. So one bit has been changed. So there is an error. Okay. Because of the noise and any external disturbances, one bit has been changed. Okay. So the one divided by total number of bits, it is the bit error rate. Actually, it is the measure of the erroneous signal. So the low PER, the better the signal is. In today's date, today's present technology, optical fiber is the latest thing. that you can send with least error and max error. Okay, there are many ways. There are numerous papers. You can go to library and write papers on error only. Error is one of the major topic of the communication systems. So one more thing, the optical fiber. If you remember, the inner core is dense because TIR takes place only when denser to relatives. The outer core is rarer. Okay. So when light is traveling through air, its speed is maximum, other than maximum, not vacuum. And when it is traveling through the dense air, its speed is less. Everyone know this? Everyone? So it will be best in our interest to send the light directly to the air. Okay. I'll tell you applications of this. You are thinking many of people have doubts कि ये तो जहाँ दिखता नहीं हम नहीं कर सकते and all that, it is not practically possible and all that. But I'll tell you applications. There's numerous applications. And the problems with other systems are RF spectrum is highly crowded, as I have told earlier. Transmission and radio waves are very low data transmission rates. It is in Mbps, but we can achieve through present technology into Gbps. These systems are less secure. Anyone can tap a wire and get the system, and he can decode it later on anyway. But when you are sent by light, you cannot store light anywhere in the sphere of signal transmission. Sophisticated electronic systems. We all have studied in the first year, second year. We all studied sophisticated electronic systems for communication. Either one way or another. Third year or second year, phase lock loop circuit पढ़ा होगा, super heterodyne receivers and all that. They are very complicated. It is very tedious work to handle radio waves, but it is very easy to handle optical because it comes in an instant. You have to work that instant only. No noise is capable of coming in that instant so fast. And it is not, of course, always possible to go down and lay the optical fiber. Suppose there is a valley. I have a receiver there and I have a sender here. Okay, I want to send a signal. With the old systems, what I have to do, I have to go physically and lay the transmission lines, either optical fibers or either transmission lines, and I have to lay the optical fibers. Then I can send the data from here to there. Okay, or I can send radio waves. But the first problem still remains. RF spectrum is highly crowded. Okay. But in this system, FS or free space optics, I can send the data through the laser and he can receive it without me going there. Okay. So, as promised, I give you an example, a very small example. First of all, we know that this laser or any other electronic device works on a DC voltage, fixed voltage, okay? Suppose it works on 5 volt. Okay? So my question is, if we increase or decrease the voltage level to some extent, will it work or not? Anybody? This device or any other small electronic device is working on a fixed voltage. Okay, the voltage depends on the cell or battery used in it. Okay, so my question is, if I increase or decrease the voltage level to some extent, will it work or not?
It will work.
What? It will depend on the efficiency. See, we have been not able to fabricate the systems that can exactly measure that. Yes, 5 volt has come, let's start. Okay, it always works in a range, and we are going to exploit this thing only. This laser, for example, according to my personal experiments I have done, it can work about 5.85 volts from 2.7 volt. This range. Okay, so you all know that data nowadays comprises of binary logic. Okay, 1 0 1 0. So what we can do, if we remain in this range, 0.85 range, and somehow modulate this wave, this DC current wave, not local laser or anything, this wave, so that it embeds logic high whenever necessary and logic low that also remains in the desired range, our data will be embedded on it. It can be done very easily by adder circuit or a transformer or subtractor circuit, anything. Okay. So our purpose will be fulfilled if we can somehow modulate this DC voltage line with our bits. Okay. It will carry our data. Carry or not? Okay. So the question arises: how can we put this thing actually in implementation? Okay. This tedious work can be done by a transformer. The transformer used for audio is EI19. It is very easily used. It is very easily available in charging channel and roll bar markets. This is the audio. It is also commonly called audio transformer. This has been used in this project. So what we have to do is to put a source in series. Okay. So what it will do? And we have put a voltage source, voltage dependent upon the laser we are using. It can be 5 volt or 6 volt, but it must be not on the edge. If you are using 5.85 volt straight away, your circuit will be burnt as your logic high is possible. Okay. So what we can do, we can send the audio signal or any sinusoidal signal for that class. It will go to transformer. Transformer will reduce the current and amplify the voltage levels, and it will be induced on the laser voltage. For those who do not know, the audio signal, the current in the audio signal are very big. The voltage level amplitudes are very less. That's why transformer serves two purposes. First, it amplifies, and another it modulates laser. So what we are doing, instead of giving a constant phase to the laser, we are modulating it. And we are giving positive bits or negative bits. Audio signal कैसा होता है? ऐसे तो होता है ना? Okay. I am advocating bits because it's not always the audio signal. Everything can be made to bits. Audio signal में तो amplitude होता है सीधा, but bits में we can use bits also. Any data. Okay. So the task of sending has been done. Only in this much circuit. Believe me. Only in this much circuit you have successfully modulated and amplified and made your sender. Receiving is much simpler. Receiving is even simpler than sending. Yeah. Why from transformer? Yes. Because transformer is serving two purposes to me. Otherwise, I have to put a transformer or add or subtractor circuit. Okay, but when I am putting a transformer, why should I put another circuit and increase the complexity of the circuit? Okay. What will the transformer do? If you have a 5 volt line, okay, you put a battery in series of it, of another 5 volt. Where will the voltage go? 10 volt. Now we are doing the same thing, but not of 5 volt, of 0.5 volt, and that too periodically or according to the signal. So here, what is the transformer basically doing is, it is sending the bits of the signal periodically to this 5 volt signal to modulate it. Getting the point? Okay. Shall I move on? So the task of receiving is much simpler. To your surprise, human brain has fabricated very wonderful things called photoreceptors. Many photos have a circuit through which sound quality is much better. I have used and variable resistance and op-amp for that cause, and adder circuit, amplifier, and custom-made amplifier available from the market, very cheap. But I cannot reveal you the circuit because it is under the process of patent. It will take 3 to 4 months to get patent of it. After all, I can reveal it. This is a typical LDR, light dependent resistance. I am holding one in my hand. It is very cheap. You can get 2 or 3 LDRs in one rupee. So you can, I have told you a technique, a secret, that you can go home and actually get a laser 20-25 rupees and get equipment of 15 rupees hardly and make your own optical communication system. So back to FSO. So is FSO a theory or is it being practically implemented on somewhere? What do you think? Anyone? Okay, I'll tell you. FSO has been used in various parts of the US and of course in the Bangalore. But tragically, it has been used in something like skyscrapers. It has we are not possible. It is not have been possible to use it in some other values, but still we can use it. Okay. So there is the data within the system, that is the intranet, which is the building system. We have been able to achieve through Ethernet or gigabit Ethernet 1 Gbps speed approximately. Okay. But what about the transmission out of the building? Okay. Here we have no transmission lines. We have only DSL cable links and transmission not fiber optic backbone. Our business will suffer and every communication system will suffer. So now FSO gives the answer. So this is one of the methods that you can implement. FSO receptors on the top of every building, and you can make a mesh that now these 6 buildings,
Six.
okay. These 6 buildings are now connected to each other with 10 Gbps speed. Okay. Now this is the actual photograph from Denver, Colorado. The system is being implemented there. So this line is not actually visible. This line I have made to show you that from this point to 2.5 2.4 kilometers approximately away, the FSO system is working, and it has been working with almost same efficiency on this scenario only, where naked visibility is practically zero. So let's move away from FSO. So let me ask you a question. What are your expectations from future computers? What do you think your computers in the future should do?
High data processing.
There will be no keyboard or mouse as such. There will be just
No, hardware. I was talking about the expectations. Lightweight. I have listed some of them there. Like there should be no heating problem. It should work as fast as possible. It should be lightweight. It should be less expensive. It should be power consumption. So power